Hey, good morning, everyone. Welcome to the TradeStation Masterclass. My name is Jesus Nava. I'm the Director of Client Training and Education for TradeStation Securities. And it's always great to meet you guys and talk a little bit about TradeStation. Today is Easylanguage, and we're going to revisit one of the topics that we've done in the past, which is types of variables, and a little bit more information on how these variables can be utilized and how you can take advantage of them. So before we jump into today's topic, let's go through some of the disclosures. Just keep in mind that every symbol and idea that I talk about is for educational purposes only. These are not recommendations of TradeStation. Also, that active trading is not suitable for everyone, and that past historical performance is no guarantee of future results. For additional information on these disclosures, please visit our website, www.tradestation.com/important information. All right, guys? It's always good to be aware of all the disclosures here. Let me switch over to my TradeStation platform and get this presentation started. In fact, I need to stay here on the PowerPoint since there's information that I need to discuss with everyone here. In the meantime, let me go ahead and get this link to share with everyone in class. This is the PDF that we're going to be using today. All right. And perfect. And as you guys notice, we have also John Brook with us today, just in case, he has some great news.
Good morning, Jesus.
Good morning, John. How are you?
Fine, thanks. How about you?
Very good, thank you. So, John, you're welcome to interject and interrupt.
Thank you. All right.
Yes, and especially when I'm, not providing, the accurate information. I'm going to present the content as somebody who's not a programmer, so it's going to be very simplified and very I guess, not to talk bad about programmers because it's a different mentality.
Easy now, easy.
But I do know that John brings, years and years of experience, so his input is going to be great. Okay, so let's get this started. First of all, let's define what a variable is. And a variable is a name that is used to represent a stored value. I'm just reading here straight from the PowerPoint. The link that I shared with you guys here in the chat is a PDF made out of this content, so you're welcome to download it. But a variable stores a value, and the value can be a calculated formula, it can be a true-false condition, or it can be a string. Usually when I talk about variables, I call them little containers because they contain something that you can always reference within your code at any time. And that something can be something simple, or it can be something complex and complicated. And one of the benefits of using these variables is that it allows you to reference sometimes complicated expressions or complicated formulas without having to retype them every time inside your code. We have a list of pre-declared variables. These are easy to use because you don't have to declare them. That's why they're called pre-declared. And they are value 1 to value 99 and condition 1 to condition 99. We only have pre-declared variables for numeric variables, which is the value ones, and the true-false variables, which are the condition ones. For somebody that programs, this can be an easy way of you testing out something inside your code when you need something to be held momentarily. But good programming practices, tell you that it's much better to create your own variables, to declare your own variables, because these make a lot more sense. So from a programming standpoint, I mean, we always recommend that you create your own variables so that there's no misunderstanding on which variable is which. If you start using this pre-declared variables all the time, value 1, value 2, and value 3, it's going to get to a point where you're not really sure what they represent. But by creating your own custom names, as long as they are descriptive, you know exactly what the variable is going to be calculating. We have two examples here, value 1 and condition 1. And you can see that whatever whatever's contained inside these variables also speaks to their type. For example, value one, it uses here the function min list, parameters close and open. So it's going to identify out of those two numbers or two values, which one is the minimum. So which one is the lesser value. And that's going to be stored in value one. So you can see that value one is numeric. It's always going to store a number. It's either going to be the closing price or the opening price of the bar. Condition one, which is another pre-declared variable, says close greater than high. That expression doesn't return a number. Close greater than high, it's either true or false on any particular bar. So we can already see that condition one is a true or false variable. If you try to use, the close greater than high and store it in value one, I believe it's going to generate an error because value one is intended to store a number and condition one is intended to store a true false expression. But again, those are the pre-declared ones. And as I said at the very beginning, when you write code, it is recommended that you declare your own variables. They're going to be more descriptive. These are going to be words that you understand better than just a standard value one and condition one. So the user declared variables, these are the ones that require a declaration statement. You have to tell Easylanguage, hey, these are the words that I'm going to start using in the code, and they need to be declared so that Easylanguage says, okay, you're creating these words. I know that they're going to show up somewhere in the code, and that's what you're telling Easylanguage inside this declaration statement. In the declaration statement, though, you also have to tell what type of variable it is. Is it a numeric variable? Is it a true false variable? Or is it a string variable? And they're actually initialized differently. If you look at the very first example, let me go ahead and turn on my laser pointer. Like over here, there's a declaration line that says variables, colon, and then it's going to list, the variables. The way that you initialize a variable, the way that you type a variable is by providing it a default value inside parentheses. So after the variable name, inside parentheses, if I see a 0, I know that it's a numeric variable because it has a number inside parentheses. The number, it doesn't really matter what number it is. We usually choose 0 just for programming, standard practices, but it can be any number. Just remember that throughout the code, you're going to be recalculating that variable. But the starting point or the initialization, if we can call it that, of the variable has to be inside those parentheses. And by putting in a number, you're telling Easylanguage, this variable is going to hold a number. Over here, the other type is true false. If you want a variable to hold a true false expression, inside parentheses, you would put the actual word, true or false. Doesn't matter which one you started off at, because again, in the code, you're gonna have the assignment. You're gonna tell what that expression is, and that's going to be either true or false. But the initialization can be any of the two words. Programming standard practices usually start these variables with a false statement because it all depends on how you're coding your Easylanguage. If you're looking for a true or a false, what I'm trying to say is that it doesn't matter what you put inside parentheses, either true or false. This is just a way of Easylanguage knowing what type of variable that is. And string, you don't see that many string variables inside of the platform, but string is when you want the variable to hold text. And the way that you initialize a variable that's going to hold text is by putting a set of quotation marks inside parentheses, which is pretty cool because when you see indicators like columns inside of a radar screen that show a particular name, we see that many times. For example, if I pull up moving averages, for example, if you have a moving average column and you want to display a certain moving average mode, maybe bullish or bearish, but you want to see the actual word, bullish or bearish, you would have to use a string variable because it holds text. All right. So we're going to look at different examples throughout the presentation so you can see the different usabilities of variables and what you can do and not. Okay, so let's go over here using the word variable. It can be used in many ways. You can see right there inside parentheses that you can say var, vars, or variables. They all mean the same thing. Doesn't matter which one you use. And after you use this word, you're gonna type in not a semicolon, a colon, and start listing all the variables that you're going to be using inside your code. Okay. Its initial value or an optional data type. There's other types that you can use in the declaration statement of variables. We're going to take a look at that in a little moment. This must be done before a user declared variable can be used in an assigned statement or formula. So what we're trying to say here is that you need to declare it first. You cannot use a name that Easylanguage doesn't know that it exists. And the only way that you tell Easylanguage that a word exists is by declaring it. So the first step when you want to use these user created variables is to declare them, is to tell Easylanguage, hey, I'm going to start using these words. If you see them later in my code, you can identify those. So first they need to be declared. Multiple variable names may be declared using a single variable statement where the names are separated by commas. We see that in many of the indicators that are built into the TradeStation platform. Usually there's only one declaration statement where you see the word variables, colon, and it lists all the different variables that you're going to be using, whether they're numeric, true, false, string. They're all listed together, separated by commas. And then at the very end, once you're finished doing your declaration of variables, you have to type in that semicolon at the very end that ends the declaration statement. One thing that you probably see, let me go over here to the code. I mean, not to the code, to the Easylanguage development environment. All right, and let me just open up anything that is built into the platform. And before I do so, the one you see right here in the background is something that I wrote. And you can see my variable declaration statement right here with the word variables. And in this example, I have two. And you can see that in parentheses, it has the number 0. So you know that these are numeric variables, or they're intended to store a number. But target price and stop price are words that don't exist in the language. How can you make sure that what you are selecting does not exist in the language? Is by the color that it takes once you finish typing it. You can notice that the two words that I picked do not turn any particular color, they're black. But if you type in a word that is blue, or if you select a word that is of a magenta or a purple color, I would try to stay away from those names, because those are already part of the language. They already have a specific purpose, and you don't want to create any conflict. So again, standard programming practices, when you're declaring your variables, make sure that the names that you're selecting do not exist in the language already. And you can tell by the color. If they remain black, it's because they don't exist in the language as a reserved word or as a function. All right. But if I open up anything that is built into the platform, let's take a look. Let's take a look at, go here. Let's do Bollinger Bands. Why not? The variable declaration statement, it's usually done this way, where you have a column of different variables. We see some other typing going on in here. If you noticed, this is different than what I did on my personal code. On my personal code, there's no typing of the variable. There's only an initialization to numeric but I'm not telling Easylanguage what type they are. If you look over here at the Bollinger Bands, we see other words like intrabar persist, we see bool, we see double. We're going to take a look at each one of these typing of variables so you can understand what they are. But for the most part, variables in all the indicators and strategies that TradeStation applies are going to be stacked in one column, but you can see they're all separated by commas, and then you have a semicolon at the very end. Does it make a difference whether you do a one-liner or whether you do a column? It makes no difference whatsoever. It's just a preference. You can do a one line or have all your variables stacked in one column. Okay, syntax. You can see what you have here at the top of this PowerPoint, and you also have it on the PDF, is all the different aspects that a variable declaration statement can have. We start with the word variable and colon. We already established that. Then whether the variable is intrabar persist, the type of data that the variable is going to store, the variable name, the initial value, and the data number if you want to reference it in here. Now, these are all optional typing of the variable. Are they required when you write Easylanguage? They're not. And that's why when you saw my personal code, I opted not to use them, because in my head, it just looks simpler. But maybe it's not the smartest way to go, because there's some advantages of typing your variables from the get-go. And that's why when we saw the Bollinger Bands, you saw some additional typing. You saw the word intrabar persist, you saw the word bool, you saw the word double, because under standard programming practices, it is beneficial to type your variable. What happens if you don't? What happens if you don't type your variable? And when I say type, is providing it a type, you know? If you don't provide a type, if you don't assign other information that is going to qualify that particular variable, it doesn't matter. Doesn't matter. Well, it matters in certain. I'm sorry. Let me take that back, because it does matter. It changes the calculation of the variable in some instances, but in some other instances, Easylanguage is kind of smart in automatically assigning a type to the variables. So what I do is that if it needs a particular type so that I can force the variable to behave in a certain manner, then I provide a specific type. But if I don't need that particular typing or that particular assignment, then I don't do it. I just let Easylanguage do its own, interpretation of my code and type the variables itself. I'm not sure, well, I know that a lot of the code that you see on the platform was probably written by John, and I know that he's going to say, well, it's better for you to type the variables, but just if you don't, it's okay, because Easylanguage will identify what type of value is being stored. There are some instances, and I think in this class we're going to take a look. We're going to take a look at some code where it is important and it is required for you to type your variable. Okay, so let's take a look at. Yes, go ahead, John.
I was just going to say, yeah, that's right. The sometimes we strictly type it. By that I mean specify the type. We particularly in some cases it's just that we might be using. Let's say we're using some objects in our variable declaration. In that case, every object will have a type specified. So for example, we might have an orders provider or an order ticket or something like that. And we'll always have to specify the type of that kind of variable. And so we kind of, for consistency's sake, we took the approach of saying, okay, for the native data type, so to speak, integer, Boolean, float, double, string. We would also show those explicitly, in part because with OO you have to show the data type. So some of it was a sort of a stylistic thing in terms of what we have in the built-in work area. And then the other thing was to sort of force a certain level of precision. And that had to do with, in part, it actually went back to 4x. And we said, well, we really wanted to specify that you were going to get, kind of 15 decimal places, a 64-bit double precision float, because we were doing some calculations with some 4x things. And this also, when we started looking at some of the cryptocurrencies, we were doing some research, and we haven't really, we don't have crypto trading within the platform, but we did research and we said, okay, boy, those things go out to a gazillion decimal places, So we said, okay, we're going to force the precision to, for example, double precision float, as opposed to possible single precision float with a kind of a 6 decimal place versus maybe 15 decimal places type of precision.
Right.
So that was a kind of another consideration, but you're absolutely right in the general case. And in most cases, the Easylanguage code is going to look at what's assigned to that variable and say, oh, what data type does that have? Oh, that's a double. Okay, make the variable a double. And so it's going to work. But anyway, just to give a little color.
Great. Great. So you're saying that it was partially done because of consistency. When you're saying that object-oriented Easylanguage, it's always visible, the type of variable.
Exactly.
And I guess we wanted to be consistent. We wanted to do that on the normal Easylanguage, or what we call the core Easylanguage.
Yes, exactly right.
And yes, and another thing that John pointed out is that when you have these forex or cryptocurrencies that use multiple decimal places, you want that extra precision. So that's an important time when you need to force the variable to be extra precise. Thank you, John, for that. Okay, so
Sure.
Here, interbar persist indicates that a variable value can be updated on every tick by default. Variable values are only updated at the close of each bar. This right here is sometimes a concept that to a certain extent it's hard to, in my case, because I'm not a programmer, because and I'll use an example for this so that everybody understands. When you create an indicator like a moving average, and you plot it on a chart, and you see the moving average calculate on every single tick. In fact, if you've done it before, you know that the line, you can see it, move in front of your eyes. So to your impression, yes, it's updating every single tick. So when I come over here, or we come over here, and we look at the board, intra-bar persist indicates that a variable can be updated on every tick. But the thing is that when I write my Easylanguage and I use a moving average, it updates in every single tick without using intra-bar persist type of variable. So what's happening here? You may be asking. And the reason why you see the moving average calculation update on every single tick, it's because it's using the closing price to calculate. But what it doesn't do if you don't use intra-bar persist is look at the value of the prior tick. You see the value updating up and down in real time, but the value that it's referencing is the value of the prior bar at the close of the prior bar. It's not able to look at the value of the prior tick. So that's the main difference. And when you do type a variable intra-bar persist, you have this extra functionality where the indicator, not only is it able to calculate on the current tick, is able to keep track of all the prior ticks before that. So it enhances the calculation. And of course, it provides you extra precision for those type of variables that need, that tick by tick tracking. We're going to look at an example that uses intra-bar persist, and you are going to be able to tell the difference on how TradeStation plots those values. Is that a fair definition, John, of intrabar persist?
Yes, that's
Okay.
excellent. Yes.
All right.
The biggest thing is right. You're right. So this gets really complicated when
Yeah.
if you dig into it and the biggest thing is whether you need to know the value of the variable on a preceding tick. Do you need to know that? If you do, you're going to need to make the variable intrabar persist so that you store that variable's value permanently, so to speak, on every tick. Whereas on a regular easy language variables, and again, this goes back to easy language code traditionally running at the end of a bar. And so you didn't really need to know what the value of a variable was the prior tick. You were always looking at what it was a bar ago. So, or more than one bar ago. So anyway, that's what happens is when you look at a variable's value, every time the code runs intra-bar, it's giving you the value at the close of the preceding bar as a default. And then if what you want is the value at the close of the preceding tick, then you're going to need intrabar persist.
Exactly. So my definition was the oversimplification of it, but it can get very complicated.
It does get a little tricky. No, you're exactly right. The biggest thing that people run into, I'll just mention it real quick, is that brackets notation refers always to bars. So you can't, even if you create a variable and you say intrabar persist, and then you put in brackets 3 ago, right? My variable from 3 ago. It's not 3 ticks ago. It's still 3 bars ago. So just don't get confused that creating the variable as intrabar persist means that it changes the way brackets notation works. I hope that's clear.
That's a great point. Great point. Okay, excellent. So, and this is, we have a question here. Let me see. Is there an option in Easy Language to use attributes to store a value permanently and do calculations? Variables take new values as time goes on. Am I right? Well, you can store values permanently using variables, right, John? I mean, and then use it as in other calculations, correct?
Yes, that is exactly what the purpose of a variable is, really. So and as Jesus mentioned, or first when we were first getting started, a variable can be thought of as a memory location, a storage location. So we're going to when we put something into a variable, we say this variable equals 5, we're storing that in a named memory location, right? So we just named the memory location whatever the name of the variable is. So anyway, that's the question of permanence depends on only what we mean by permanent. Like, do we mean between times we close the platform and reopen it? Because excuse me, that would be something different. But if we're just talking about till the next time the code runs, then a variable storage is permanent.
I see. Okay, thank you for that, John.
But yeah, we can look at specific examples.
Yeah. So we saw, for example, here, the intrabar persist type of typing that is used here in this variable in a chart. So when we look at the PDF here and the syntax, intrabar persist can be one of those qualifiers of your variable name. You can also use the data type, which can be float, double, integer, bool, string, or class. Of course, this goes back to what we were talking about when it's the precision that you need for that particular variable. Now, I'm not really familiar with other type of data types like class or bool. I've seen most of the time I've seen integer if the variable does not need any decimal places, or double if you need that extra precision. We've used float, which is somewhere in the middle between integer and double. I think I provide No, I don't provide it. There's I think an extra, another slide. I provide a little bit more definition between integer, double, and float. But bool, what is a data type bool, John? Can you provide a little bit of insight? Because when I came over here to the code of the Bollinger Band, this is a bool data type in a chart. What does that really mean when you
Yeah,
type it?
we use the bool terminology, short for Boolean, this gets a little tricky. Let's see, what would be a good function? I'll have to think of a function off the top of my head, but we use the term true false more in the context of functions. So for example, when you have an input to a function, the types are numeric simple, numeric series, true false simple, true false series, and so forth, as the type of an input to a function. The bool notation also is the exact same data type. It's a true or false. Under the covers, it's an integer, but it's a 0 or a 1. But true or false, we use that, specifically the words true, false, simple, true, false series, and so forth in functions only. And in studies, we use bool. I hope for that data type, but it's just a true, false, binary kind of data type. It's either, yeah.
Now, my question, John, is, for example, in this particular variable declaration, would it change the result if we remove this bool, or is this is just
Oh, no, sorry.
no.
No. Right. No, it will assume if you're assigning that as false, the default value is false, we're going to presume that that's a bool.
Oh, so it's okay, perfect. So I
Right.
just
No, just for clarity, and consistency and so forth. Yeah.
okay, perfect. So it just refers to false, true, false variables then. Okay,
Correct.
pretty
Sorry.
cool,
Yeah.
pretty cool.
Misunderstood.
So yeah, so you can use a data type also as part of the declaration. Then your variable name, it's a user specified variable name. You have the initial value, which we talked about. This is pretty much, telling Easylanguage what type of variable this is going to be, whether numeric, true, false, string. And then you have an optional data number. For those that use multi-data charts, you know that you can add up to 50 data elements to a chart analysis. And in the declaration statement, you can, from the get-go, you can already tell Easylanguage this variable is going to use such data number. Of course, you can do that also in the assignment. In the assignment, when you tell Easylanguage what the variable or how the variable is going to be calculated, you can also use a specific data number, but it's interesting that you can include that inside the declaration. Now, what would happen, John, if you have a data number here in the declaration, and then in the assignment, you start using a different data number? Will there be an error?
No, it'll compile. This gets really, really complicated also, but let me give you the short version is we need to decide when to permanently store the variable's value. Do we store the variable's value at the data 1 interval, at the data 2 interval, at the data 3 interval, or when? So, because those bars could close at different times.
Mm-hmm.
And it's, again, we're assuming you're not intrabar persist here.
Correct.
So when are we going to store that variable's value permanently for the next? We need to know that. So that's when we use what we call aliasing. So if you declare it an alias the variable's value in the variable declaration as you have there, then we know that we permanently store that variable's value at the close of that data stream's bars.
Mm-hmm.
Okay, and we're going to presume, so, okay. Then the question of how you interpret a reserved word in an expression. So for example, if you say my variable equals close, Well, which close? Data 1, data 2, data 3, close of which data stream? That is going to be determined by the aliasing that's provided in the statement in the code. So anyway, this, as I say, gets quite complicated because potentially you could refer to close of data 1 in a variable that's alias to data 2.
So let me ask you something. If in here I would put in like data 5,
right?
Sure, and my variable I assigned, okay, var name is going to be equal to the close. That close will be data 5.
That close, no, will be data 1.
Data 1. So it's in the assignment is where you have to specify. It's more important to specify the data number in the assignment than.
Well, yeah, it can be. Okay. Yeah, that's what I say. This gets real complicated. But okay, let's say that we alias in the variable declaration to data 5. And I look at that variable's value 7 bars ago. 7 bars of what? 7 bars of data 1 or 7 bars of data 5?
Okay.
It turns out that if I alias the variable in the variable declaration to data 5, then a bars back reference also refers to the alias data stream. So it'd be in data 5 if I create. Now, the reserved words, which is what you're talking about, remain all by default alias to data 1, unless we, in our expression, say close of data 5. So in your case, you said, okay, but if I back reference that variable and it's alias to data 5, it'll be 5 to data 5 bars ago, not 5 data 1 bars ago.
I think I understand. So
all right.
Here, so when you use the data number here inside the declaration statement, this controls the frequency in which the variable is going to be updated.
That's correct. It permanently, when it's permanently stored. Every time the code runs, it'll get assigned. The variable will get assigned a value. But when does it store permanently? And why does that matter? For the purpose of back reference with brackets.
Right. So in your calculation, if you're using close of data 1, yes, it's going to use the closing of data 1, but the variable, if you have data 5 up here, is going to be based on the time frame used in data 5, and it's going to store values based on that data 5. Right? That's
a way to look at it. Yes.
Okay.
It could be a class unto itself about the multiple data streams. It can be complicated. It really depends on what a person's doing in the code, but anyway.
Okay, perfect. Great. That's great information.
Great
information. Okay, some remarks to keep in mind when you're using variables. First, it can contain up to 20 alphanumeric characters. You can use the period, and you can also use an underscore. But a variable name cannot start with a number, or it cannot start with a period. The default value of a variable is declared in parentheses after the variable name. I think we've said that multiple times already. Multiple variable names may be declared using a single variable statement where the names are separated by commas. We said that already as well. And the use of the reserved words variable, var, vars, and variables is identical. All right, so everybody got that? That's just to refresh what we said about variables and some things to keep in mind when you're naming, when you're setting them up in your declaration statement. Okay. We have a question here in the chat. Suppose I want to keep track of open and the end price in a single bar, and I want to keep track of these values for each bar. Do we need to define a separate variable for each data point? I would say yes, of course. If you want to keep track of the open and the closing price on every single bar, I would, my understanding of programming, yes, you need 2 separate variables to do that. Can you store
You just need the 2, right? And you don't need a different variable for each bar. You can back reference the existing variables to get historical values, for example, of the open.
Right.
or the close, but you would need one variable for opens and one variable for closes, and at
Yeah.
every bar they'll store.
Because variables cannot store different values of one bar, right?
A
Like for
single
example,
variable would
a
just
single
have
variable.
one
Okay,
value. So
got it.
in the case of the open and close, and again, you don't even need a variable. Actually, you can back reference open, close, high, low.
Hmm.
You can back reference those things without storing them yourself.
That's right.
So anyway, many
Yeah.
keywords in Easylanguage are like that, but not all.
Yeah, those data points already exist in the database. It's just a matter of referencing them historically, correct? All right, types of variables. Let's see. Numeric, very straightforward. It's just a number. True, false, we talked about it too. The variable holds either a true or a false expression. A text variable, we talked about it too, the one that you initialize using a set of quotation marks, double quotation marks. So you have two double quotation marks inside parentheses, and it saves text in a variable. Just as here, there's no pre-declared string variables. The only ones that are pre-declared are the numeric and the true false. So you have numeric or value 1 through value 99, and the true false pre-declared are condition 1 to condition 99. All right. Three main data types: strings, numerics, true, false, or booleans. The numeric ones are further broken down into subsets like integers, floats, and doubles. I think we talked about that too. If you already know that a particular variable is just going to hold an integer, meaning no decimal places, maybe it's a good program in practice to type it as an integer. So int would be the way that you do that for an integer. Or a float, as you can see right here in this little table, it's a precision that goes down or up to the 7 digits on a decimal place. And the double is the one that goes up to 15 digits. Do we have extra precision, John, that you know of, or is 15 decimal places the maximum that Easylanguage uses?
Well, okay, we have another data type that not very frequently used, but it's an int 64. So you,
Okay.
instead of typing int, you can type int and then the digit 6 and 4. So an int 64 has 64 bits for a positive number, 64 bits that can be used. So, but again, that'll get into number one, the numbers get very large, and number two, but so for example, we actually use that under the covers for volume storage, because of volume values, as you guys are probably aware, they've gotten huge on some symbols. So over the years. So anyway, there in Int64 is used, to be able to handle the large volume numbers.
Interesting.
And we it's nice to use an int because we know volume is always going to be, there's no decimal places on it unless you get into things like crypto, right? So this was one of those wrinkles of some of the new stuff, or if you got into fractional shares. Okay, so yeah.
Good. Thank you for that. So for integers, we use int or int64 if you want that extra precision. For the most part, a lot of the variables. For the variables that I use, in my code is my code is usually very simple. So I usually don't type my variables, but if you know that a variable will hold an integer without decimals, sometimes it's smart just to type it, but it's not required. Float for single floats and the word double for double floats. Okay. Let's see, the type is identified at the beginning of the variable declaration. So you have the variable declaration. Notice how this is a int var1, 0 is a numeric variable that is going to be an integer, or a numeric variable that is going to be a float. So the typing of the variable goes before the variable name. Required? No. Necessary? Sometimes. Depends on how what these values will hold. And when you get the plot, when you get to, plot the indicator on a chart or inside of radar screen, sometimes it's going to be very telling if you need to, specify what type of variable they are. So Easylanguage will auto detect if you don't specify the type of variable. All right. Predefined variables are set to double so that we have that extra precision. And let's talk about intra-bar persist a little bit so that we can, I said that we're going to create a little sample code to show you how intra-bar persists works and how it's different than, an indicator that updates in real time. So let's go ahead and do that. I don't think there's any. We're going to use bar status in this example. Bar status is a very cool reserved word that tells you where you are inside of a bar, if you're on the opening tick, if you are on the closing tick, or if you are in a tick in between. I use it many times just to make sure that I run a calculation on a certain bar event. So these are the numbers that it returns. If it returns a number 2, then you're on the closing tick of the bar. If it returns a 1, you are in a tick within the bar. And if it returns 0, you're at the opening tick of the bar. So sometimes you want to have that precision as to where am I in the duration of a single bar. And when you use intra-bar persist, it makes sense because it's running the calculations on every single tick. So let's go ahead and take a look at this piece of code that we're going to write together here. So let me do that here. I'm going to create an indicator. All right, I'm going to call this !JN intra-bar persist count. I think I have one that has that name already. So let's do count 2. Since I did this, or I'll do counter. Okay, so my variables, I'm going to set 2 counts. Count 1, and this will be numeric, and count 2. And this will be numeric as well. And this way you can see the difference of one versus the other. So count 1 is going to be equal to count 1 plus 1. And count 2 is going to be equal count 2 plus 1. What does that mean? That on a bar, what I'm expecting this to do is to count every time we have a tick, to automatically increase the counter by 1. That would be my impression. What I'm going to do here differently is set one of these variables to intra-bar persist. Intra-bar persist. One way to know if you mistyped the reserved word is to know if it turns blue, it's because you did it right. If it doesn't turn blue, check the spelling. Intra-bar persist. So that's my counter number 1. So what I'm going to do is plot the 2 values. Plot 1 is going to be count 1. I'll call this count 1, 2, just so that I can keep track. And plot 2 is going to be count 2, count 2. Okay? So if we keep a counter over here, we need a way of resetting the counter. And I'm going to reset the counter based on a bar event. When the bar closes, I'm going to tell this indicator to reset the counters to 0. So let's do that. So because I want the counter to only work as the bar is building, to keep track of the counter as the bar is running in real time. Once it closes, I want it to reset and then start over again on the next bar. So in order to reset, I need to use bar status. I'm going to say if bar status for data 1, so you have to supply, you have to supply inside parentheses what data are you looking at. I'm looking at data 1. If the bar status equals 2, which is the closing tick of a bar, then begin. I'm going to say count 1 equals 0 and count 2 equals 0. So I'm just resetting both counters to 0 every time that I have a closing event. So let's verify this. Okay, I'm going to maybe go to properties. Let's change the chart style. I'm going to turn this into a histogram. Let's make it thicker so that we can see what they are. Histogram. And let's click OK and verify this. Let's use this on a chart. So apps, chart analysis. Okay, this is Home Depot. It's fine. Let's go here to studies, add studies. And this will be exclamation JN, intrabar persist counter. Okay. So something is, there we go. So, okay, so what's going on here? There we go. So you see the counter here, and you can see it here on the right-hand side as well. On this 5-minute bar is keeping track, at least plot number 1, which is the intrabar persist, is keeping track of every single tick. And you can see that plot number 2 is down here on the blue at still at 1. The reason why we have this plot number 2 at 1, it's because it's referencing. Now, let me ask you something, John, because if plot number 2, this one that's showing up down here, I suppose is showing the one from the close of the prior bar, right?
Well, right. It's saying, it's saying, okay, count 2 equals, I can't remember if you use count 1 or count 2, but count, let's just say it's count 2. It says count 2 equals count 2 plus 1. And it's, okay, so what is count 2?
Exactly.
Well, for a non-intrabar persist, it's the value that it had at the, excuse me, at the close of the prior bar. So it does what we call pushback. It says, okay, look at the value from the close of the prior bar and add 1 to it. And so on each bar, then that variable, if you went to like a 20-second bar or something, and and then you'll see on each bar it's going to increment, gradually start going up.
Okay, which is happening. Right here. So this, on the next bar, you say that this one will go to 2? Correct,
exactly.
Because
it's non-intrabar persist, and so at the close of the bar it stores permanently. On the next bar it says, whoa, does what we call the pushback. It says close 2 equals close 2 plus 1. What was close 2? Oh, it's the value from the close of the prior bar, whatever that.
Yeah. So let's go here to a 10-second bar just to have a little bit more activity. So on a 10-second, of course, we see the ticks accumulating on the red histogram, because that's the one that's intrabar persist. But here on the second plot is
right.
It should be incrementing on every single bar.
Correct. And maybe switch to SPY or something, and then we'll get this thing
moving fast.
And you're moving along. That's right.
Fast. All right. So.
Okay. And then gradually you should see, I can't really see that blue very well. Maybe change that to cyan or something. And
it's stuck at 1.
Oh, it's stuck at 1.
Yes. So let me go here and do that one. Color of 2. Let's do a cyan. So yeah, it doesn't increment. But yeah, you're right. It should, on every bar, it looks at the prior. Yeah, so what do you think?
Maybe go back to your Easylanguage code again. I think you're setting it back to 0. Okay, that's the problem.
Okay, so at the close, it's setting it to 0.
Right.
So every single bar is adding 1.
On that one, it's right. Exactly.
Oh, I see. Interesting. So since there's no connection to the closing price, you see in a moving average, you have connection to a closing price because it's being used in the calculation. And that closing price, of course, is updating every single tick. And that's why it seems like the moving average, well, it seems no, it's updating in real time because the closing price changes And as it changes, the value of your variable changes as well. But
Exactly.
it's always in terms of the variable as of the close of the prior bar.
Correct. Correct. It's taking the current tick's price and averaging that in with the closing prices of the preceding, whatever, 20 bars or however long your
Right.
moving average is. So the preceding 19 bars plus the current tick, that gives you the 20, you sum them and divide by 20 to get the average. Yeah.
Right. Let me ask you something. Intrabar persist should work in radar screen too, right?
Yeah, that's right. Yep.
Okay, so I'm gonna put it here.
There's some additional complexities, but we'll cross those bridges when we get there. Yeah.
Okay, let's see. So I'm gonna do intrabar persist here with the counter. And I think I have to give the indicator additional bars for calculation.
That'd be good. There you go.
Okay,
See
so
that'll right.
Let me right click here. I'm gonna say general, load additional bars. I'm gonna say 100. Okay, when I try to use this indicator, this is what I got last time I used it, and I wasn't sure why counter 1, which is my intrabar persist, was not showing me an incremented value.
Okay. So that is an interesting question.
It doesn't have to do anything with the way that this is update value intrabar. It's set to
Okay, so let's go back to the code again.
Let's go here. Okay.
And at the very bottom, type value 99 equals ticks.
Value 99 equals, I think we did that in one of the examples for Easylanguage, right?
Right. Now re-verify that.
Okay. Verify and go to the trade station. Ah, there we go.
Yeah. And
so what's happening? Could you explain
all
that?
All right. Yeah, sure. Okay. Okay. All right. This requires a little bit of history. Radar screen, since it can run on up to 2,000 symbols with quote fields or up to 1,000 with historical data requests, it can put a load on the platform when you're calculating tick by tick. Imagine calculating on every tick a moving average of 200 bars for 1,000 symbols, right? Crazy. So you're starting to put a load on. Okay. So for performance reasons, we said, okay, let's look at the code when we compile the code and see if the code really needs to run all the time. Because for performance reasons, if we don't need to run the code, we won't. So we said, okay, well, what kinds of things are updating intrabar? Well, close, open, high, low, those kinds of things. Ticks. Oh, yeah, okay. Do we have that sort of reference in the code? Does the code refer to something like close or ticks or that kind of thing that'll change from one tick to, oh, it does? Well, we need to run that code. It doesn't? We don't actually need to, unless the user forces it to, which you can do with what we call an attribute. But anyway, the point here is that when you add the value 99 equals ticks, when the code is verified, we say, okay, this code needs to actually run definitely every time we get a tick. So we do, and that's why that forces what you can do. You say, well, that's gonna, why do I need? You could put that behind a once block if you want to. It could just say once, value 99 equals ticks. It'll only run the code once, but it'll cause the code to have that characteristic.
But wouldn't that characteristic be set by intrabar persist? I mean, you're kind of telling it, hey, I need this calculator on every single tick, right?
Well, okay. That's, yes, you could think of it, there may be some enhancement that we need to do on that. The intrabar persist is telling it when to store the variable, but not when to run the code.
Oh,
so there's a little difference, but you're right. I mean, it's a little bit subtle. And again, in some way, the attribute I was referring to, if at the top of the code you wanted to, you could type an open bracket and you could type same tick opt, all one word,
Plain, tick,
opt.
opt.
Yep. See how that turned gray?
Yes.
Equals
Oh, equals.
false, close bracket. And that you'll see will verify. You can verify the code now. And that will prevent, it is one of the ways that we prevent, actually, this attribute, I think I got to look again. Actually, and maybe we can cover this in our next Easy Language
Yeah,
Answered.
for
But
sure.
the same tick optimization actually has to do with same price ticks, not with the optimization for. There's another attribute, and the name is slipping my mind. But there's another attribute that we can use to say. I think. I'm not sure. I believe there's an attribute we could use that would replace the value 99 equals ticks, but I can't remember the name off the top of my head, and I'm not positive now that I'm thinking more about it that it works that way. So
Sure,
value
yeah.
99 equals ticks is as good a way as any
Okay. Okay. Yeah,
to
I guess
force the code to,
to know that we need that tick kind of calculation. Makes sense.
correct.
Could you have used close price here too, or
You could have, absolutely,
okay.
yes. Anything that has the
That changes on a tick by tick basis.
correct.
Okay, perfect. All right, great. That's it.
All right.
That's our class for today.
All right.
So yes, guys, you know that John is with us every other week. You know, I wanted him to be here because I knew that he could fill in, some of the areas where we need a little bit more, technicality and a little bit more details about how the functionality works. Because I know many people here are programmers, so I wanted John to be here to share his expertise as well. So thank you, John. Thank you, John, for giving
You're
us.
welcome. My pleasure. Great to be here as usual.
Everyone, thank you again for joining us today. Have a wonderful afternoon, and tomorrow we'll join me tomorrow for Ask the Experts at 11:30 platform Q&A, and then we have another session at 12:30 in the afternoon. Okay, have a wonderful day, and I'll see you guys later. Thank you for being here. Bye-bye.